So let's summarize everything that we've done so far, and then I want to look at some mapping notation and some replacement notation. Okay, so we'll get to that when we get there. This is compared to the graph of y equals to f of x. Whenever we have an a up front, remember that that's a vertical. Okay, it's a vertical. Now, what does that mean? This results in a vertical stretch. Okay, a vertical stretch about what axis? Now remember, if you're not sure, do a quick sketch. Think about it. We're going to stretch this guy in this direction. So what axis are we going away from? We're going away from the x-axis. So it's a stretch away or about the x-axis by a factor of just plain old a. Well, that's cool. But what happened when a was 0? Remember, when this was negative. Okay, when this was a negative value, we also remember that it was reflected in the x-axis. That's what's really, really important here. Okay, so basically, let's look at this. To stretch anything, all you have to do then is multiply the y-coordinates. Remember how those invariant points didn't change? Because why? Because they were zeros. None of the x's changed either. Only the y-coordinates were affected by this lovely right here, by this a value. Okay, that's why we call it a vertical stretch factor. Okay, so let's look at our mapping notation. This one's going to be easy. Of course, if we got a point x, y, like we said, it's going to be mapped to something. We said the x values stay the same. It's only the y values that are multiplied by a. Oh, okay. So that's one of the reasons why when we had a point like that one that was 0, 2, and we said the stretch factor was 3, we said that this is 0, 3 times 2, which then became 0, 6, which was our image point. Okay, but I got a question for you. If we're going to go into this function y equals to f of x, and I'm going to do this guy now, replacement notation. How am I going to do replacement notation showing this? Well, let me show you something. I'm going to clear this out of here. I want to show you some really, really, really cool stuff. You know and I know that this is originally y equals to a f of x, right? But remember, if it's going to be a vertical, we want that. We want something to deal with y. We want the emphasis on the y. So here's what we do. Let's get rid of the a. Let's divide both sides by a. Boom. So you're going to have something that looks like this. Y over a equals f of x. And look, there's the stretch factor. Granted, it's in the denominator. So what? But now the emphasis is with the y's or the y coordinate. There's a replacement notation. I'm going to show you how this works right away, and this is going to make all kinds of sense. So let's go to the replacement notation notes here. It says value of y in the graph of this is replaced by a over y. Or I should say y over a. Oh, there's my dyslexia getting the best of me. So watch this. If I actually pop that in there, if I pop that in there and do the replacement just like we talked about and went y over a equals f of x, think about this. How do I get rid of the a in the denominator? That's right. Multiply both sides by a. That cancels, leaving you y equals a f of x, which is exactly what we were talking about way the heck back there, right here. Ta-da! Okay? So think about it. If it's written this way, though, the emphasis is on the y-coordinate. Now, I know what you're saying. How does this affect that other stuff? For example, watch. When we said that we had y equals to 3 f of x, and we said, oh, that's that wonderful question we did 4 times. That was the 4 minus x squared, right? Okay? Now, how do I write this with emphasis on the y? Real simple. Just divide both sides by 3. This is y over 3 equals to the square root of 4 minus x squared. Done. That's it. There's the emphasis on the y. And again, granted it's in the denominator, but so what? It still works out quite nicely. Okay, so your mapping then would be take the y values and replace them by y over 3. Okay, generally take the y values and replace all the y values by y over whatever that scale factor is. Okay, and it looks a little weird right now, but don't worry, we'll get you through it.